Good morning, students. Today's session, we are going to discuss about the depth limit first depth limit search (DLS). So last class we have discussed on the depth first search. Okay, so what is the meaning? What is the use of this the depth first search? So how we are able to perform the depth first search in our algorithm format? So what kind of data structures are used? So everything we have discussed on that. So now we are going to discuss about the depth limit search. So that is called as a short form is called as an DLS. So DLS is very similar to DFS with predefined limit. So what is the meaning of this one? If the length may be very infinite path, okay, so the depth limit search can solve the drawback of the infinite path in the depth first search. If it is goes beyond this now, so it is very difficult to find the depth first element. So what is the basic idea of DLS is not allowing the expansion after the certain depth also. So you just note it down. So this is called as an the depth limit search, and this technique proves to be the most useful for finding the maximum depth of the solution. So this is called as an depth limit search. Another one more thing is we are able to perform the depth limit search operation. So how we are going to perform the depth limit operation? So we are having considering the three important points. One is this the sense. First one is set the depth limit to the maximum depth. So first one is we need to set the depth limit that should be the maximum depth. Second one thing is we are going to initialize the node as an current node, and if the node may be an goal, so you just return the node, or otherwise if depth of initial node greater than the depth limit, so we just check it. If the depth of the initial node that should be greater than the depth of the initial node, or depth of the depth limit means so automatically it should return the value, or else means what is this? That is expand the initial node and we need to find out the successful successor using the stack and go to the step 2. Okay, so this is the way we are going to represent that the depth limit search DLS. So what is the four steps. So first one thing is set the limit, depth limit. Suppose if the branch is going down, or that is we need to set the limit to the maximum depth to the search. This is the first step. Another one more step is that so it is we need to initialize the node that is in current node. If the initial node that should be a goal node, that is we can return the value. And third one is if the depth node, if the depth of the initial node that should be greater than the depth limit means, so we just return, or otherwise we have to expand the initial node and save the successor using the stack data structures and go to the step 2. Okay, so this is the way we are able to perform the depth limit search. Another one more thing is the depth limit search so does not complete. Okay, so it does not find any solutions in all different cases also. Another one more thing is DLS is the memory efficient. So it is will be the very memory efficient, and it is not an optimal one. So we are not able to perform the optimal process or optimal one. Another one more thing is if the depth limit is greater than that, if the solution's depth, then it should be a complete one. So we are going to discuss the four important aspects. One is this DLS is not complete since it does not find any solutions in all the cases. Another one more thing is it does not an optimal one, and DLS is the memory efficient. And if the depth limit is greater than this the solution depth, then it is a complete one. So this is the way we are able to perform the operations of the operations of the DLS methodology. So you just see this. So what is meant by the DLS? So if the depth limit goes very lengthy, or it should be a very there is infinite path that should occur in between the depth first search. So definitely we can go for the depth limit search. We need to set the limit on this. Another one more thing is there is the depth idea. Okay, so the basic idea of the DLS is not allowing the expressions also, and this is an algorithm. Another one more thing is these are all the some features of depth limit search. Another one more thing is the informed search. So what in by informed search means the uninformed searches that leads to the higher time, as well as this. This is an the data are not organized properly, or that should not be organized in well in advance. So uninformed searches leads to the higher time as well as the memory complexity. Another one more thing is optimizing the search problem, and optimization of the whole process are the challenging task. So another one more thing, we just take some right heuristics, as well as the right application of the heuristics are the some important techniques. So thus there is a need for an informed as well as the heuristic search, and this is also a heuristic search technique that should be, or some other strategies that should be followed for the informed search. So informed search means some other data that should be provided in well in advance. So these strategies use the information about the domain, common knowledge about the problem and the scenario to move towards the goal state also. So we are able to do this. So heuristic methods do not always to find the best solution, but not guaranteed to find the best solution in possible it's of amount time. Oh, so this is another one more the important point. Another one more the very classic examples for the heuristic method is an TSP problem. So here, what about the informed search problem is that the heuristic function that plays a major role, and that is here. This is a function that should provides the guide of the decisions of the selection of the path. Okay, if the heuristic function h of n provides and estimate of the cost of the path from the given node to reach the closest to the goal node. Okay, so there is another one more the important aspect for performing the heuristic function. Yeah, heuristic function is one of the guide or some decision takes place between the selection of the path. Second one more thing is that the heuristic function h of n provides an estimate of the cost of the path from the given node to an the closest to the goal node. So next one is generate and the test function. So what about the generate and the test function is so here we just focus about the easiest way to solve any kind of problems for generating the solution, and check if this is a real one. So what is the meaning of this one? The method, the algorithm for the method is given below. So here we are going to consider the three possible methodology. One is this: generate the possible solution, which can be the node in the problem or space, or it can be the path from the initial state. Second one is the test if the problem solution is the real one, or compare with the goal states also. So this is the second one. And the third one is check the solution if the true, return the solution, or else go to the step one. So we are able to perform the generate and the test function for solving their entire the problem for the process. So you just note down that kind of things. So this is called as an generate and the test function. Okay, so and so in this section we are able to perform the, or we are able to discuss the two different topics. One is this depth limit search, as well as the informed search for generating the test and the search functions also. So this is the idea about this the basic depth limit, depth first depth limit search, as well as this the informed search. So here in this informed search, the heuristic function plays a major role for making or guiding the decisions of the selection of the path. If the heuristic function provides an estimate of the cost of the path from the given node to reach the closest goal node for the process. Okay, so you just noted. So this is the way we are able to perform the informed search process. Okay, got it. So that's all about the these two concepts. Okay, thank you.